Hi, hello everyone. Once again, welcome back to my channel. So in this video, I am going to discuss with you all ETO COC December 2023 written question paper. So this exam was recently conducted on 18th of December, and usually ETO COC exam is conducted on every third Monday of the month unless it is a holiday. And those who are new to this field, let me tell you, ETO CSC exam is conducted every month. So this exam is about certificate of competency, which is you can get after 4 months of PDC course and 8 months of onboard training. So once you are done with this, you have to clear one written and one oral exams. Okay, so let's start with the discussion. Examination of electrotechnical officer, grade is ETO, and function is electrical, electronics and control engineering. Subject is Marine Electrotechnology and SSCP. This exam is of 100 marks. Total time allowed is 3 hours. And these are the instructions. So total there is 3 sections, and out of every section you have to attend only 2 questions. So total 6 questions you have to attend, and all questions carry equal marks. Neatness in handwriting and clearly expression carries weightage. Illustration of answers with clear sketch diagram carries weightage. Start answering from back side of the front page, and blank pages if any to be strike off by cross at the end of each questions. Okay, so this is section 1, question 1, 2, 3, and this is section 2, question 4, 5 and 6, and this is section 3, question 7, 8 and 9. So any 2 questions out of these 3 you have to attend. And before starting the discussion, I want to share with you all one analytics which I have done. So this is the analytics of questions which is asked in section 1 and 2. So from which topics what questions are asked. So as you can see, section 1, this is the question of September 2023, section 1, section 2. So these 3 questions, number 1 was from induction motor, number 2 alternator, number 3 power system. In section 2, question was from control system, AC circuit, transformer, DC motor. In the month of August 2023, first question was about battery, induction motor, control system. In section 2, question was from power system, electronics, transformer, alternator, DC machine. July, induction motor, power system, induction motor. In section 2, transformer, induction motor, AC system, 3-phase system, circuit theory. In June, first question was about induction motor, alternator, power system. In section 2, it is electronics and induction motor. So this analytics I have done, from which topic which question was asked, and I found out that topic from induction motor, it is repeated many times. In the month of September, 16 marks. In the month of August, 16 marks. In the month of July, 16 plus 16, 32 plus again 8 marks. So 40 marks from induction motor only. In the month of June, 16 plus 16, 32 marks. In the month of April, there was no question from induction motor. In March also, there was no question from induction motor. In the month of February, 16 marks and 8 marks, 24 marks. In month of January, 16 marks. December, 16 marks. November, 16 marks. October 2022, 16 marks. September, 16 marks. This is 8 marks. August, 16 plus 16, 32 marks. 16 marks. So as you can see, induction motor chapter is repeated many times, and same was done in the December 2023 question paper also. As you can see, this question, obtain speed regulation of 3-phase induction motor, rotor resistance cascade, 16 marks. Question number 3, with reference to squirrel cage induction motor, describe construction of such a motor. All questions 16 marks, 32 marks. Then question number 5, show how power transferred across air gap of a 3-phase induction motor, 6 marks. So 16 plus 16, 32 plus 6, 38 marks. Again this question, synchronous speed of a motor, this numericals, again 16 marks. As you can see, out of 150 marks is from induction motor only. So how is important induction motor? And induction motor, all the topics are covered. This is about speed regulations, and this is about construction, torque, and device used to improve the part load performance. This is about power generation, types of power, explain what portion is useful power, and this is about synchronous speed and one numericals. So from all sections of the induction motor, questions are asked. So I believe if you cover the induction motor chapter, you take any textbook of electrical machine and you should read the complete induction motor chapter. You would be covering 25% portion of your ETO COC written exams. And same thing I have also done. Let me show you my notes when I was preparing. So this, and I have also done the same thing when I was preparing. I had this analytics done in the month of July only when I was reviewing my exam. So spherical induction motor, I covered all the topics, all the notes I made, the circuit diagram of induction motor, the torque, speed, all the graphs, torque equation, constructions of induction motor, torque and speed curve motor, so how power is transferred across air gap of induction motor, compare method of speed regulation. So as you can see, the full topics of induction motor I have studied, and also the starter, dual starter, some numericals, and this is power transfer, how the power is transferred and what are the different terms, what are the formula, questions are asked from this also, effect of reduced voltage on burnout, starting torque, speed, full topic I have studied. And this helped me also because in the month of July so many questions was asked from this topic. As you can see, July, induction motor, induction motor, induction motor. So 16 plus 16, 32, 32 plus 6, 38 marks was asked from induction motor chapter. And since I had already prepared properly for this topic, I easily passed in my first attempt. So this is how I can tell you how important is induction motor chapter for your written COC preparation. Okay, so let's get back to the discussion of the question and answers. Question number 1, compare methods of obtaining speed regulation of three-phase induction motor. First method is rotor resistance, cascade system, and pole changing. Give examples where each system may be employed. So this question I have prepared my notes. I will show you. Same question I have prepared, as you can see, and I have made notes also. You can refer my notes. I will just explain in very brief what is the answer of these questions. As you all might know, the speed of induction motor can be controlled. The speed can be given by 120 F by P. So by changing frequency or by changing pole, we can change the speed of induction motor. So the first method is rotor resistance. So rotor resistance is only used in the case of slip ring rotor. So only resistance can be added in that type of rotors. As you might know, there are two types of rotor for induction motor. One is squirrel cage induction motor and another one is slip ring rotor. So this is done by adding additional resistance on the rotor side. So if supply voltage is reduced due to added resistance, the developed torque decreases. Hence, for providing same load torque, slip increases with decrease in voltage and consequently speed decreases. This is the equation you can write. Now, what is the advantage of this method is that control provided from rated speed to lower speed. So speed can only be reduced. It cannot be increased after the rated speed. Design is very simple. Advantage: large starting torque, low starting current, and large value of pull-out torque at in small value of slip. So these are the main advantage of this. What are the disadvantage? Speed above normal value cannot be possible. Large speed change requires large value of resistance, which causes large copper loss, hence efficiency reductions. So adding resistance always produces heat. So we will be losing power. Not suitable for squirrel cage induction motor as addition of external resistance is not possible. So only in the case of slip ring we can use this method. Now what are the applications? Used in equipment where continuous speed changing required. Cargo cranes are fitted with this control. Highly recommended to be used in the intermittent load application because of low cost, high torque capability at lower speed. Used in boiler combustion fans, pumps drives where speed variations over a small range near max or top speed is required. And the second method is cascade system. So in this system, usually two motors are connected. So two three-phase induction motors are connected on a common shaft. One is called main and another is called auxiliary motor. Now three-phase supply is given to the primary motor, that is stator of primary motor, and while the auxiliary motor gets supply at the slip frequency from slip ring of the main motor. And now this cascade set of two motors will run at two new speed having number of poles P1 plus P2 and P1 minus P2. So total four number of speed is possible, that is P1, second is P2, then P1 plus P2 and P1 minus P2. And if both motor produces torque in the same direction resulting in P1 plus P2 poles, and it's called cumulative cascading, and if opposite direction it's called differential cascading. So P1 minus P2 poles. So as I told you before, N is equal to 120 F by P. Now if we change this P, our N is going to change. So P1 one speed, P2 another speed, and P1 plus P2 another speed, and P1 minus P2. This total four speed is possible in this step. Now what is the advantage of this? Stronger mechanical characteristic, low rectifier voltage drop, low noise, simple maintenance. And what is the disadvantage? Rotor circuit is equipped with a reactor for filter, so power factor is low. The application is usually this is used in the winch operation. Three speed is winch, auxiliary blower, electro assist, turbochargers. So this is a very brief answer. You can, if you want to write more also, you can write from this, but I think this much will be enough. Just writing what is cascade system, what is advantage, what is disadvantage, what is application. These things are only asked. And the third one is pole changing. So usually this one is also changing the number of poles, but in this two motor is used and creating a cascade system. And in this type of system, a stator is usually provided with two number of windings. So different number of windings will create different number of poles. So NS is changed by changing number of poles of a stator winding, mainly used in cage motor because cage rotor develops number of poles equal to poles of stator winding. Number of stator winding can be changed by multiple stator winding, method of consequent poles, pole amplitude method. So usually stator winding is changed, and for changing stator winding, three methods are used: this, and this. Harder mechanical characteristic, very good stability, no slip loss, high efficiency. This is the advantage. Simple wiring, convenient control, and low price. The disadvantage of this is that cannot achieve smooth speed regulation due to large grade difference, because number of poles is changing from P1 to directly P2. So speed is not gradually changing up or down. So there is a sudden speed change. Used where variation is fixed will like 2 or 3 speed. What I can remember from my CP is that in my engine room, the engine room crane that is having the same. It is having 2 speed for lowering or for raising the load. It's having 2 speed, high and high. Forced draught fan, winch motor, purifier, feed pump. So this is the application of this system. Question number 2 says, tank liquid level sensor are integral part of ships. Describe with aid of suitable sketch the working principle of A. Capacitive type level sensor, B. Ultrasonic level sensor, and C is float. Now to answer this question, I would like to refer you to the Elston Fernandez sir book, that is Marine Control Technology. Elston sir was also my faculty at SIMS when I was doing a pre-C course. This is a very good book from him. So this is the book. So this is the book which is very good for everyone, for those who are starting their career, those who are in the middle of their career, those who are preparing for the exam. And this book deals with all types of sensors. So in this you can see level measurement, article 3.6. It deals with all types of level measurements, and our question deals with ultrasonic level sensor and tank radar system capacitive level sensor. So the level measurement starts from this page number 124. You can read all this part. You can take a screenshot from the video and read it. I'm not going to explain. It's a very big topic. So for your understanding, if you want to understand this topic, how the level is measured with different types and different types of sensors, this is a very good book, very good contents in a very simple language. It is explained. Differential pressure transmitter for boiler level water measurement. This is a very common question in the oral exams, how the water level of boiler is measured, how it is monitored. Okay, so if you want the full knowledge, you should refer Elston sir MCT book. But to answer this question for the exam purpose, this is explained here in point wise. The first one is capacitive type level sensor. So capacitance level instrument operates on the basic principle of variation of electrical capacity or capacitance of a capacitor formed by the sensor, vessel wall and dielectric material. A capacitor is made of two conductive plates which are separated by a dielectric. This is a definition of how a capacitor is formed. Now, suppose this is your tank in which liquid is stored. So this one rod is inserted inside this, and this rod and this the outer layer of the tank, it forms a capacitance. So once the liquid level changes inside this, the capacitance of the this sensor changes. As C is given by A epsilon 0 by D. So once the liquid level changes, the dielectric medium is changing and this is changing. So capacitance also is changing. So the change in capacitance gives us the change in the level of the liquid. So capacitive probes are used in liquids that are non-conductive and have a high dielectric constant. You can write all these points in a point wise and can be used for continuous level monitoring. A capacitive probe zone consists of an inner rod with an outer cell immersed in the liquid that we intend to measure. This is the rod I am talking about. The capacitance of probe is measured between inner rod and the outer cell with the aid of a capacitance bridge. In this portion out of liquid, air serves as a dielectric between the rod and the cell. In the immersed section, dielectric is that of the liquid that causes a large capacitive change as the level of liquid changes. So as the liquid level goes up, the air, this is the air part, this changes, so the capacitance changes. If the tank is made of non-metal, the inner rod will be surrounded by the another metallic outer. The capacitance change is directly proportional to the level of the liquid. The dielectric constant of liquid must be known for this type of measurement. Yes, the dielectric constant of process material is the most important aspect of this level measurement application. It should be noted that temperature, moisture content, humidity and density can change the dielectric constant of process material. These factors are often taken into account and corrected for in the design of capacitive probes for level measurement. Now talking about the ultrasonic transducer. So this is diagram. In this design, level sensor is located at the top of the tank in such a way that it sends out signal waves in form of burst in downward direction to the fluid in the tank level. As soon as directed sound waves hits the surface of the fluid, sound echoes gets reflected and returned back to the sensor. So the time taken by the signal to come and hit the surface and then again get back. So this time is measured and in this way level is measured. Speed of sound waves can be sometimes affected due to variation in temperature for which appropriate compensation needed to be provided in the sensor design. In general, medium over the fluid surface is air. However, one can employ a blanket of nitrogen or any other vapor also. Fixed components only hence requires less maintenance and hence less leakage problems. Disadvantage, not suitable for materials like powder etc. Heavy vapors, surface turmoil and foam, ambient noise and temperature do not work satisfactorily in areas involving vacuum or high pressure condition. Next is float sensor. A magnetic float level indicator shown in this schematic consists of a float chamber, a float and an external indicator tube. A float chamber is a column of pipe with connection to match the tank whose liquid level. The fixet moves up and down inside the chamber as the liquid level changes. Float type and materials are determined by the properties of liquid being measured. So this advantage, disadvantage, complicated piping and installation, not suitable for double bottom tanks, blocking of tubes. Now coming to the question number 3, with reference to a squirrel cage induction motor, describe the construction of such a motor, sketch the torque against speed curve of such a motor, describe a method employed by a retrofit device used to improve the part load performance of an induction motor. So answer to this question is also in my notes, construction and parts of a squirrel cage induction motor. So you can Just draw a simple diagram of induction motor. You can explain the parts: shaft, bearing, conductor, skewed slots, bearings, end rings. There is two parts, stator and rotor, the three windings on the stator. All this explained. They are 180-degree apart mechanically and electrically. These windings are either star and delta connected. Then stator is mounted in such a way that it provides low reluctance path for generated flux. Insulation between winding is varnished or oxide coated. Rotor is cylindrical core which is laminated to avoid power loss. It is made of aluminum or copper bar which are placed parallel to each other. So you can add 2 to 3 more points about this. Now sketch torque against speed curve of above motor. So there is no induced torque at synchronous speed. Torque speed curve is linear between no load and full load. So this is the curve you can see against the torque and speed. So if you want to read more about this, you can refer any textbook of electrical machines and read this. And to explain section C of this question, there are three main ways to improve power factor: capacitor bank, condenser, synchronous condenser, and phase advancer. So you can draw this simple diagram of capacitance connected into the motor to improve this power factor. Improving power factor means reducing the phase difference between voltage and current. A capacitor or bank of capacitor installed parallel to the load provides reactive power. So in this way methods we can improve the power factor of the motor. Okay, now let's move on to section 2. So in the first question, question number 4a, explain the significance of root mean square value of alternating current and voltage waveform. Define the form factor of such a wave. So this is a very simple question. I'm sure you can get answer to this, but I will show you what my answer is when I was preparing. So just take a screenshot of this and read full. That's all. It's a simple definition only. You can get on the Google also. No need to discuss much into this. Now coming to the numerical part of this question B. A 72 kVA transformer supplies a heating and lighting load of 12 kilowatt at unity power factor and a motor load of 70 kVA at 0.766 lagging power factor. Now calculate the minimum rating of power factor improvement capacitor which must be connected in the circuit to ensure that transformer does not become overload. So this is a question from transformer chapter. I have solved this question here for you. I will just very quickly try to explain to you how I have solved it. It's a question in which it involves power factor. Only two formula is important. One is power factor, this one, kilowatt by kVA. Power factor is equal to kilowatt by kVA, and this formula I have used in this to solve this question. Okay, so let's check now what is given in the question. So transformer capacity is given 72 kVA. So this is the total capacity of the transformer. Now there is two type of load: 12 kilowatt load at unity power factor and 70 kVA load at 0.766 power factor. So the question asked here is minimum power factor improvement to avoid overloading on the transformer. So let's first calculate what is the total kilowatt load on transformer and then total kVAR load on the transformer. So this formula I am going to use. So power factor is given 0.766 kilowatt you have to calculate and 70 is kVA. So we can easily get kilowatt here. So kilowatt is 53.62 kilowatt. Now total kilowatt is 12 we already have from this and 53 we calculated from this. So total kilowatt we have is 65.62. This is a total kilowatt. Now let's calculate what is the kVAR requirement. So now I am going to use this formula. kVAR is equal to kVAR is equal to kVA into sine phi. Sine phi we can get by cos inverse of power factor. So we have power factor here. So 70 is kVA, 70 into sine phi. So we are getting kVAR requirement is 45 kVAR. So now we have these two parameters. Kilowatt load on transformer is 65.62 and total capacity of transformer is 72 kVA, and this is watt. So we can now calculate how much the transformer can take load of kVAR. So this is the formula for kVAR. I am going to use kVA square minus kilowatt square. So we have kilowatt, we have kVA. Now subtracting, we are getting total 29.63 kVAR. So our requirement is total 45 kVAR, but our transformer can take only the load of 29.63 kVAR. So extra power factor improvement we will be requiring will be 45 minus 29.63 kVAR. So this is the answer you can get. This much of kVAR, this much of reactive power we need to give from extra from outside, either by using a condenser or capacitor bank. Okay, now as the video is getting too long, it's almost 25 minutes now, I would like to explain the rest part of this question paper in my next video, as I don't want the video to be too long, just 20 to 25 minutes or 30 minutes max to max I want the video to be. So I will end this video here, and I would like you all to give me the feedback and suggestions. How do you like it? Do you guys want me to make the discussions of all the month question paper? I will start doing it November, October, September, before all the months. At least 1 year question paper I will discuss, so that it will be easy for you all to give your exams. So please do give me suggestions, and if you find any mistake, you can come back to me. You can write in the comment section if any doubt, if you have, or if I have spoken something wrong or somewhere wrong mistakes you find, you are always welcome to me, and you can give me suggestions. So thank you, and see you in the next video.